Let V be the set of all real polynomials, P of x. Let transformations T and S be defined on V by T multiplies P by x, and S takes a polynomial to its derivative. And interpret ST P of x as S of T of P of x. Which of the following is true? So ST equals 0 is definitely false, right? If I multiply something by x and then take a derivative, I don't necessarily get 0. ST equals T is also certainly false. ST equals TS is definitely false. ST minus TS is the identity. So one of these is true. Let's maybe start to rule these out one by one, rather than me just arbitrarily saying why they're false. So to show that this is false, all I need to do is find a polynomial such that T of P, so S of T of P of x is not equal to 0. Well, let P be equal to 1, the constant polynomial. Then T of P is just equal to x, and S T of P is equal to 1. Great, not 0. B, ST equals T. So I need to find a polynomial that gives me different expressions on both sides of this. This should also be pretty easy. So I want to find polynomial P to substitute in here to give me different expressions. Let's let P equal x this time. Then T of P is equal to x squared, and S of T of P is equal to 2x, which is not equal to x squared. Okay, and C, ST is equal to TS. I can let P be equal to 1 again, right? Then ST of 1 is equal to S of x, which is equal to 1, but T of S of P of 1, this is equal to T of 0, which is equal to 0. So these are not equal. Okay, D. Yeah, so D and E, I'm not sure which of these is true from my, I'm not sure, my instinct isn't really telling me which one of these is true. I could write out a general polynomial P and just apply transformations in both directions and see what happens. So I guess it's the difference is the one that's the identity. Yeah, so the answer is D. The difference of these two things is the identity. You can just going through the computations, assuming that we're starting with an arbitrary polynomial of degree k, working out what all the transformations are that we need to, kind of makes it work. I suspected that one a little bit more than E, just because by adding things together, you're kind of things are getting bigger. I should have been able to rule out option E quickly in my mind somehow. Not sure exactly what was holding me back there. But anyway, that's the answer. ST minus TS is the identity map of V onto itself. If I have more to say about this one, I'll put it in the description. Thanks for watching.